Alright, so let's look at this question here, which is on hypothesis testing. So, a manufacturer claims that his new battery management system, when installed in electric vehicles (EVs), can help to improve the driving range. So, to test the claim, the system was installed in 100 EVs of a particular model. Now, take note, if we say improving, meaning this cannot be two-tailed, right? It has to like improve. So, essentially, the driving range is known to be mu naught km per charge, right? So when recorded, these are the things. A statistical test is carried out at 5% level of significance, and it's found that there is an increase in driving range. Find the range of value of mu naught. Now, essentially, the idea is when someone comes to you and say, "Hey, guys, this thing very good. It helps to increase the performance of a battery, right?" So you don't take its words for it. What you're gonna do is actually this case here we have like 100 EVs here. Then we test, okay? So this cannot be two-tailed, and take note, we need to use CLT because it's not known to be normal, right? There's not known to be normal here. So I'm gonna write the standard stuff. Let X be the and then let mu be the so this is it. Then once done, what we're gonna do is actually just write all the other stuff that we need. So H now. So if you claim to help out, H now is this is the assumed knowledge. Right? Everybody knows that it will travel mu km per charge, right? But in order for you to be better than that, what you need to do is a mu, because this data would then reject the what do you call it, the common knowledge, the general knowledge, like the common assumption. Okay, so mu naught. So this is, you use the data to test against the mu naught, because preconceived notions, pre general knowledge will tell you that it's mu naught km per charge, right? Then after which you take the test, and in order to reject the claim of general knowledge, you need to reject on the right tail. So write everything down. 100 cars, and then level of significance is 5%. Then we need X bar and so on. X bar, you just take summation of X minus 240 divided by 100, then add back 240, right? For summation of X squared, we just take 1 over n minus 1. It's just a translation of 240 units in the, so you just use X 240. This is from sampling. Okay, so sum of X minus 240 square over n. Just key in calculator. What we'll get is 1280 over 33. Okay, great. Then what I could just use, now you have to use classical method here, which is the rejection zone method, because we need to find the range of mu naught. Okay, so by central limit theorem, you have to write this down approximately, because the population is not known to be known, but the sample is approximately normal. Okay, so essentially I would like to draw the normal distribution out, because to visualize this, understand that the closer you are to the mu, which is actually mu naught here, okay, the more true you are. H naught is true here. Okay, this is the truth. Then what you need to do is actually understand that we are actually rejecting on the right side. So this guy will be 5%. 5% level of significance. This is what we call Z critical. Okay, so I'm just going to inverse norm Z critical. That will be inverse norm, just Z critical here. Distribution Z critical, inverse norm 0.05, then 0 and 1, then right side. Okay, you get 1.64485. All right, then after which we know that in order to reject, we want to reject H naught, right? Just an increase in driving range. So increase will mean that H naught rejected. So meaning to say your Z statistic, okay, have to fall within the, Z statistic have to fall within this region. You need to reject H naught. Because take note, if the closer you are to this middle, you do not reject H naught. Okay, so the more H naught is true. So this will mean that Z statistic is actually more than Z crit. Okay, Z statistic will be X bar, which is 248 minus mu naught, so over s square, which is square root 1280 33 over, what is the answer? 100 more than 1.64485. So what you need to do is just solve this inequality here. So this is 1280 33 over 100. Then I'm going to key in calculator and then just solve this. So essentially you could write down, hence mu naught could be less than 2 for, if you want to be strict, it would be 2.6. If you do not want, you can just round up as well, it's fine. It's not so strict, okay? So don't just think that, yeah, 247 km. So these are all 3 SF. Okay, both are acceptable. It's just depending on what, okay, you could just use 246 at most, okay? For this is at most, this is less than, so it's fine, okay? So that's how you do this question here proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.